Virtual Machine Sequencing Part 1. Finally, we have arrived at the real fun stuff, and that is writing a program for a virtual process. It would be nice if we had this actual process to ship around to our live classrooms. And it would be nice if we had everybody out there had one of these to play with, but it's a virtual process. Taking a close look here, you have two conveyors. You have a feed conveyor and a finished product conveyor. The feed conveyor is driven by M1, motor 1. The finished product conveyor is driven by M3, motor 3. And then we have another motor involved, and that's the drill motor, M2. But leave that aside for right now. We have raw stock from upstream, the green box, and we've color-coded our boxes, our steps, based on inputs and outputs. The light blue is a sense, and then the orange is a react or action. So sense and action. And we've got the first sense in darker blue, step 1, just to make it easier to find on the page. We have product that comes through on the feed conveyor, and we're just doing this 2 dimensions, so they're round. If you want to visualize something 2.5, 3 inches tall with a hole in the center, you can do that. And as these products come in, the feed conveyor pulls them in, and they can either be pushed off into the workstation or pass on through to another workstation downstream. So all of the product that comes in on this feed conveyor gets read by the barcode reader. And if the part number is less than a certain value, then one thing's going to happen. If it's greater than a certain value, then another thing's going to happen. And you could have written the logic either way. If the barcode reader, it reads the code on the product. If the code on the product signifies that it doesn't need a hole drilled in it, a hole bored in it, then it goes right on through on the feed conveyor down to the next station. However, if the code read by the barcode reader signifies that this product needs a hole bored in it, then when it gets down to photo I2, which is the second sensor, so photo I1 senses the part and triggers the barcode reader. So 1, PE senses part, 2, barcode reads the barcode. And then 3 is PE2 senses the part. Now, if the part isn't meant to be pushed out into this workstation, then it goes right on through when PE2 sees the part. But if this product is destined to be processed in this station, then when the part hits photo I2, blocks the optical path, then cylinder 2 is going to extend and push it into the V block on the other side of which is the drill motor. Now, it just so happens that we laid out our I/O based on some minimum amount of I/O available. So we are actually controlling cylinder 1 and cylinder 2 with the same solenoid valve. So you see we have 2 boxes marked cylinder 1 extends. Step 4, cylinder 1 extends. Cylinder 2 extends. Both of them extend together. Cylinder 1 extends to block any other parts from upstream from getting down to cylinder 2 extended and getting hung up on the cylinder. Cylinder 1 and cylinder 2 extend when the part is in the optical path of PE2. That pushes the part into the V block on the other side of cylinder 2 in a position to have a hole drilled in it. Next thing that happens is once it's in position, and keep in mind that we have proximity switches or position sensors on both ends of all the cylinders. We have 5 cylinders, and there are 2 prox switches on each cylinder. So when cylinder 2 is fully extended, meaning prox 2 senses the position, you might have a little delay after that to make sure that it's fully settled. But nonetheless, what's going to happen is the drill motor is going to energize. So we've got step 4, we extend the cylinders. Step 5, prox 4 sees end of stroke. Step 5, prox 2, end of stroke. So both cylinder 1 and 2 see end of stroke. And then 6 is drill motor on, M2. And we want the drill motor on before we try to drill. We want it up to speed. So an action is drill motor on. The next action is a 3-second delay before we extend cylinder 4. Because when we extend cylinder 4, that's going to send the drill bit into the part and bore a hole. The next thing we're looking for, step 8, is that cylinder 4 is fully extended. So you see 8, prox 5. So cylinder 4 is fully extended. And then step 9, cylinder 4 retracts. Now we might have a delay in there between 8 and 9 to make sure that it's fully extended. Cylinder 4 retracts. And then 10, prox number 6, sees that it's retracted. And then 11 turns the drill motor off. And again, there might be a delay in there to ensure that the drill bit has had time to empty all the shavings off of it. But that's not critical. So 11, the drill motor went off. And then 12, well, the drill motor goes off, and then we retract cylinder 1 and 2. When you look at 11, drill motor off, you see 2 other 11s. So 11 over by cylinder 4, drill motor off. And then 11 over on the left side, there's 2 of them. Cylinder 1 retracts, cylinder 2 retracts. And then after they retract, step 12 is, there's 2 step 12s, and that is the retracted proxes, prox 1 and prox 3. They sense that cylinder 1 and 2 are retracted. And then we can go to step 13, and that is cylinder 3 extends to push the finished product out onto the finished product conveyor. And then step 14 is the prox 8 senses that cylinder 3 is fully extended. And then 15, cylinder 3 retracts. Once cylinder 3 has retracted, it is out onto the conveyor. 16 is that prox 7 senses that cylinder 3 is fully retracted. And then 17, the conveyor is turned on. The finished product conveyor, motor M3, is turned on. And then 18, photo I3 sees the finished product in its optical path. 19, cylinder 5 extends. 20, prox 9 sees that it's fully extended. And then 21, it turns the conveyor off. Now there's some variations of this. If we want the product to continue on downstream, then we would not extend cylinder 5, stop 2. So as we work on this process, we'll go through quite a few changes. So like I said, this is the fun part. You may want to photocopy this page and have it to look at while you are going through the process, because you're going to be looking at this for at least 60, 70 pages of lab projects. The first thing we did was create a rung of logic that simulates cylinder 1 extending. This logic is not foreign to you. We've used it before. And this time you can do it without thinking so much about the logic as other than the big picture. So what we're doing is we're looking at the cylinder 1 extended solenoid. Now, I have B320/0 because I'm going to work with all internal bits initially. So instead of using, O:0/something, an actual output, and keep in mind the only difference between B320/0 and output 0/0, it's a different spot in memory, but it's still just a bit in memory. Whatever turns on B320, in other words, whatever turns on the solenoid to extend the cylinder, is going to start a 2-second timer, at the end of which it will declare that cylinder 1's extended prox has been made or sees the cylinder fully extended. So this is the first step in creating a virtual cylinder. Next up is this is extending what would retracted or retracting look like. Now we have extending and retracting. Notice that instead of using two outputs or simulated outputs for solenoids, we're using a single solenoid spring return pneumatic valve to control our cylinder. So when we energize the solenoid, it shifts the spool, routes pressure to extend the cylinder. When we de-energize the solenoid, the spool shifts back and reroutes the pressure to the rod side and retracts the cylinder. So we have simulated extending and retracting, and we gave each of them 2 seconds. Now in the manual I made this one a little less, with the idea that normally you extend under load. In other words, you're pushing something, and when you retract there's no load other than friction. So normally extending takes a little bit longer than retracting. To just throw in some worthless realism, I shortened the preset on the retracting time element. Download, go online. Right now the solenoid is de-energized, and when you first downloaded this, you probably saw this timer accumulating because this rung is true. If I toggle on the extend solenoid, you can see that this went off, and after 2 seconds this went on. When I toggle it off, now you can see it's retracting. So there we have logic that simulates the time element of telling a cylinder to extend, and then its extended proc sensing it extended, and then de-energizing the solenoid, and then there's an interval before the cylinder 1 retracted proc comes on. Now notice that neither one is on when we're in motion, so watch closely. Neither one is on, then it's extended. Watch again. Neither one is on, then it's retracted. So this perfectly simulates using the bit that controls the solenoid with timers to simulate the amount of time it took to get off of the retracted procs, which is on right now, and get to the extended procs. And to further tidy up the logic, I had you combine both of these rungs into one rung simply to keep them together. Just so you can see that it still works correctly. The reason we combine these is because we want them to stay in one spot. We don't want them to get separated with other rungs of logic in between, because it's easier to read and operate it right here. We tell it to extend, 2 seconds later it's extended. We tell it to retract by turning off the extend solenoid, and 1 3/4 seconds later it's retracted. Works perfect. Next we replace B320 with an actual pointer that points to a bit that's going to control an output. And the easy way to do that is to put this in the edit mode and then double click on the symbol, Control C, delete, and then type in your output address, which is output 0. So 0/0 will do. Then we double click there, Control V, and voila. Drag this down to here, and that much is done. The next thing we had you do was to duplicate this piece of logic for cylinder 2. Now in our scheme we are controlling both cylinder 1 and cylinder 2 with the same solenoid. So this much of it right here, true if on, output 0, true if off, output 0, that stays the same. But we use T4 0 and 1 for cylinder 1, and we're using T4 2 and 3 for cylinder 2. So you have to change all of these other pointers to match. Be really careful, because it's really easy to overlook something and leave it in its original state or its original format from you copied it. So what I did was I selected this rung, Control C, Control V, and created this second rung. So all of these memory locations or pointers match this first rung. So you have to go through and make sure you change all of them except for these two right here. So that takes care of cylinder 1 and cylinder 2. Now for cylinder 3, you can click on the in statement and do you can't do a control V if you used your copy paste to copy some of these tags and then change the 1 to a 2. So I'm going to go back to here. I'm going to do control C. Then I'm going to click here and do a control V. So this gives me a copy of cylinder 2 to work with for cylinder 3. Okay, now I have 3 cylinders done. And if we've done our memory management correctly, you notice I'm using T40, 1, 2, 3, 4, 5. And then for proxies, I'm using B3 word 30 bit 0 and word 31 bit 0. The bit numbers match for extend and retract proxies. It's just the word is different. I have a pattern that I can follow. Now if I look here, I have cylinder 3, cylinder 3, cylinder 3, 3, 3, 3, 3, 3. That's always want to check that when you're doing copy paste. Focus is here, control C, control V. Now you could have copied this once and pasted it multiple times. What I like about doing it this way is that you're looking at the previous number, so it's easy to see, okay, this is 3, I need to make it 4. I think I gave you the option of testing each of these individually, and the way to properly test them is to toggle one on, times out, that bit comes on, and when you toggle this one, that should go off, and this should not come on until after the delay. Okay, so right now the retracted is on, so I'm going to toggle this off. The reason that some of these are on is because in our last project, I was using these bits and I left them on. That's data table Carney. So now they're all off. When you test one, 2 seconds, extend is on. So you should go up and make sure that the retracted are off. And I see here it's not, and here's why. Exactly what I told you not to do is what I did. Now I have cylinder 3 extending here, and it should be cylinder 3 retracting. See, T44, this should be T45. So I overlooked because I only looked at the cylinder number and not at the timer numbers. Do as I say, not as I do. Okay, so now we look and we see all of the retracted proxies are on, except for this one, which we did extend. So now let's send that back off. Go up to the next one, extend it, retract it, extend, retract. And it doesn't matter which one you use. You right click on this one or this one. If you toggle it, you're just toggling it. Extend, retract. You see, that time I did them in the opposite order, but the function was still the same. So all this code has been tested. So we now have 5 virtual cylinders, and we have virtual sensors, 2 sensors for each cylinder, that respond with time delays from when we tell it to extend or we turn this off and let it retract.